we're going to revisit this painful memory and write down some of this stuff on scrap paper. We know that I'm starting at rest in this situation. We know my acceleration is 1.2 meters per second every second, and we know I had 5.8 seconds before I reached my top speed. What you don't know already is that I can maintain that uniform velocity for about 6.2 seconds before I get tired and I start slowing down. One other fact, the displacement from my room to the stairs is 68.5 meters. So we have some other details to this problem, and here's what we're going to solve. If my door, room 231, is the origin of this coordinate system, we establish towards the stairwell as being the positive direction. What displacement will I have during my 5.8 seconds of accelerated motion at 1.2 meters per second squared? Will this get me to the end of the stairwell? If not, will I make it before running out of steam? And how long would it take me? That is the problem we want to do now. So hit pause and see if you can solve it in your composition book. In a multi-step problem like this, it's best that you just focus on each task. The first task, what displacement will Mr. Black have during his 5.8 seconds of accelerated motion at plus 1.2 meters per second squared? So you really need to solve that first. We don't know the displacement, we're trying to solve it. But what do we know? Well, if you look, we know our initial velocity. When I say I'm at rest, that implies it's 0 meters per second. We also know my acceleration. So given the things that we do know, we can see that probably the best equation to use here would be the third motion equation. D equals VIT plus 1/2 AT squared, because I have a lot of these variables already. I even know my time. So I'm going to go ahead first and plug in some of the information I have, my VI being 0 meters per second, my T 5.8 seconds, my A being 1.2 meters per second squared, which we have here, and then my T 5.8 seconds. Now the first step I'm going to do is this end here where I'm going to go ahead and square my time. 5.8 seconds times 5.8 seconds would be 33.64 seconds squared. Now I know as far as sig figs go that's an issue, but I'm not rounding yet. We don't round until we're near the end. So let's still keep that even though the precision is obviously too much. Simplifying further, since the first part of this term is 0, I can just focus on the second part. So I can put in my calculator 0.5 times 1.2 times 33.64. You'll notice seconds squared cancel out. It's important you always do your dimensional analysis. If we're supposed to be solving displacement, we should only be left with meters. So that's what I have in my calculator. But is that what I would put? Again, let's look back at our precision. We are stuck here with a final calculation that was multiplying with 2 significant digits. So we have to follow the rules. You only have 2. So the answer would be 20. I should write 20 point or 2.0 times 10 to the first. So a little error there. It's still confusing. You're just going to have to remember it's 2 significant digits. So we can see we got a while to go. I've only made 20 meters when I hit my top speed. So depending on whether we're trying to solve now or keeping our significant digits till later, we have a while. That answers my second question. Will this get him to the end of the stairwell? Sorry, it won't. I only got 20 meters. That's far short of 68.5 meters. How short? Well, 49 meters short if I'm doing correct sig figs, but I'm going to still work with 48.5 until we're done with the entire problem. Don't round till the end. So if not, will he make it before running out of steam? How long will it take him? Now, if you were paying close attention to this, we know we can actually use uniform velocity equation. There is no acceleration going on because it said when I reach my top speed that I won't be gaining anymore. So I can use displacement equals velocity times time from chapter 2 because my average velocity equals my instantaneous velocity. In other words, there's no acceleration. So what is my velocity I would use? Well, if we go to our previous video, the video on motion equation 1, we know that we could have solved, and we did solve that. My final velocity is my initial plus my acceleration times the time I traveled. So that average velocity will be my final velocity after I accelerated. That's going to be 0 meters per second, that's my initial, sitting in the chair, plus 1.2 meters per second squared times 5.8 seconds. That's where I got 6.96 meters per second, or effectively, as far as the precision we have, 7.0 meters per second. So I know my V. And if you're taking good notes, I know my T well. I know I had 6.2 seconds of that uniform velocity before I tire out. So I put in the terms I know. I can calculate them. I have my velocity, I have my time. The seconds cancel out, so I'll get meters. And we could see during the uniform velocity portion of my run, I'd make 43.4 meters. Again, with significant digits, 43 meters. But that is a problem. That still is not what I needed. Remember, I needed about 48.5, 49 meters. So I'm still 5.1 meters short. And to be honest, I can't answer the question how long it will take unless I knew my acceleration at the end when I get tired. So all we do know is I didn't make it. I just didn't put in enough, probably lost my job.